This is week 8, day 3, countdown, final countdown papers. Let's move in. Right. First one. A point source of sound emits sound equally in all directions. Sound is traveling in all directions equally. For such situations, the sound intensity at a point is inversely proportional to, I is inversely proportional to the square of the distance. Inversely proportional to the square of the distance. If the intensity level at a distance of 5 meters is 70 decibel, the intensity level at 50 meters will be, be a bit careful now. So 50 means far, no, lesser. So if you look at it, delta beta 10 log I1 divided by I2, right? 70 minus beta 10 log, closer the better, (50 divided by 5 whole thing square), right? Far you go, beta reducer, so there's a difference. Initial is bigger, I1. Final is less. I1 1 over 5 squared, 1 over 50 squared. 50 squared goes on top. Right. 70 minus beta 10 log 100. Log 100 is 2. Beta is equal to 50 decibels. So 50 decibel, answer 3. In the circuit shown, cell E and ammeter have negligible internal resistance. Negligible internal resistance. Right. When the voltmeter has a resistance 2000 ohm, is connected across, so 2000 ohm here, current will divide, no? So what will happen? If I connect across there 2000, effective resistance here, now here it's 2000, here becomes 600. Effective resistance reduces. Are effective reducers, current will increase. Ammeter reading will increase. Ammeter reading will increase. Resistance reduces, so voltage reading will reduce. The voltage across XY drops and the ammeter reading decreases. Statement 1 is correct. Earlier it was 1000, E over 2, E over 2. Now this reduces even further. So ammeter reading will increase. No? Voltage across XY and PQ remain the same, wrong. Both voltage across PQ and ammeter reading increase, wrong. Voltage across PQ remains the same and ammeter reading increases, wrong. So what's happening here? Voltage across XY will drop and ammeter reading will increase. Effective resistance reduces, increases. So ammeter reading increases. Right. So correct. So ammeter reading increases. Here resistance is less. Here resistance is more. Here voltage is more. So correct answer is answer number 4. Correct answer is answer number 4. Right. Next one. In the figure shown, A is a torch bulb. B and C are light emitting diodes. If a strong bar magnet is moved up and down continuously, why are you sending up and down continuously? To create a sinusoidal voltage, to create a sine curve, right? Generates a peak voltage of 4 volts. Right. What will happen? Right. Look at the board carefully. Now, positive half means high potential, low potential. Negative means low potential, high potential. Right. High potential, low potential current will go, low to high it can't go. So A will illuminate continuously. A can illuminate continuously. What about B? What about B? Here it's going to be rectified, brought in one direction. Brought in one direction means this will be reverse bias. That will be reverse bias. Reverse bias means C will not work. So whatever answer with C is wrong. So what will light up? Positive, negative, both. Positive cycle, yes. So my correct answer will be only answer number 2. Right there. In both the positive and the negative half, A will illuminate. In both the positive and the negative half, A will illuminate. B will illuminate only in the positive half. B will illuminate only in the positive half. Because in the negative half, it will be reverse biased. It will be reverse biased. It will be reverse biased. After the rectification circuit, C will always be reverse biased, so it will not illuminate. C will always be reverse biased, so it will not illuminate. So it will not illuminate. Right. 3 masses made of material having densities ρ1, ρ2, ρ3 and equal volumes are connected together by light string. System floats in a vessel containing 2 immiscible liquids of densities ρ4 and ρ5. Consider following conclusions. Right. ρ1 is smaller than ρ5. Okay. B. ρ1 is smaller than ρ3. So this sinking inside, it's been held. Right. Tensions of the strings are equal. If tensions are equal, ρ2 equal ρ5. So here there is a upthrust. Here there is a upthrust. Here there is a upthrust. So if you just basically take the full system, U1 plus U2 plus U3 equals V ρ1 plus V ρ2 plus V ρ3 G. Here V ρ4 G, V ρ5 G, V ρ5 G, V ρ1 plus ρ2 plus ρ3 G. All the V's cancel off. ρ4 plus 2 ρ5, ρ1 plus ρ2 plus ρ3. Full system. If I take this separately, V ρ4 G minus V ρ1 G that is equal to tension T1. Tension D2. V rho 3G. V rho 5G. That is tension T2. Rho 3, rho 5. Here separately you can write T1 equals V rho 2G, V rho 5G, T1. This one. Right. So anyway, why is it floating? This is anyway trying to go up. Rho 1 is smaller than rho 5, correct. So guaranteed that is correct. Rho 1, rho 3 is lower, no? Correct. If the tensions are equal means you can equate certain things. No? Rho 2 and rho 5. Tensions are equal. Tensions are equal. T1 equals T2. Rho 2 equal rho 5. So here you have V rho 2G, V rho 5G. T1 is there. So this one is there. Right. Tensions are equal. Here T1, here T2. Rho 4 minus rho 1, rho 3 minus rho 5. Rho 4 plus rho 5, rho 1 plus rho 3. So if I simplify this, rho 5 equals rho 2. Correct. ABC all are correct. ABC all are correct. Right. Figure shows a cross section of an integrated circuit mounted on a circuit board. The core of an IC electrical circuit dissipates 60 watt of power. Core is converted into the material of thermal conductivity 6 watt per meter per Kelvin. Direction of heat flow is shown in the figure. So from here on heat is going out. Top surface of the IC is cooled by forced convection. Top surface has an area 10 centimeter squared. 10 centimeter squared with a thickness of 90. At what temperature the top surface kept not maintain core at 90. So this theta, right. So Q dot is equal to Ka delta theta over delta L. 60 watt. K is 6. Area 10 centimeter squared. Convert to meter squared. 90 minus theta 1 millimeter. There you go. First multiply it. 60 cancel off. Theta is 80. 5. Answer number 2. Theta is 80. Very quickly you can find it. Ideal gas undergoes cyclic process ABCA. BC is isothermal path. Work done by the gas during one cycle is nearly equal to. So these are anti-clockwise cycle. Let's take a triangle. Half base into height. 450 kilojoules. Network input. Input is minus. And since it's less than 450, minus 300 kilojoules. Minus 300 kilojoules, answer number 4. Anti-clockwise cycle. Therefore, work input. Work input is negative. It is less than 450 kilojoules. Right. A soap bubble is formed gradually at one end of a glass tube T equal naught by slowly blowing. Now remember, it will become slowly, gradually. What happens is, the radius will become bigger than the tube. Radius will become bigger than the tube. One instant equal to the tube. Then again bigger than the tube, then falls out. When the excess pressure, when the radius is minimum, excess pressure maximum. Excess pressure maximum means, correct answer is answer number 4. When the radius of the tube and the radius of the bubble are equal, excess pressure is maximum. Right there. When the radius of the tube and the radius of the bubble will be equal, excess pressure will be maximum. Excess pressure will be maximum. A heavy metal box is to be supported by n number of uniform identical legs made from the same material. Entire weight of the block is equally distributed among all the legs. In this situation, the variation of the contraction of each leg with the number of legs due to weight of the box. Right. So, heavy metal box is to be supported by n number of identical legs made from the same material. The entire box is equally distributed. Okay. So equally distributed means same force. Same force means same compression. Same force means same compression. When the number of legs increase, the force will reduce. Compression will reduce. Young's modulus is stress over strain. F over A, X over L. F proportional to X. F proportional to X. Force will reduce, so contraction will reduce. Force will reduce, so contraction will reduce. So when number of legs keep on increasing, the force will also start to reduce. Force will also start to reduce. When the force starts to reduce, the compression will also reduce. Yeah. So can we say it's a linear variation? Can we say it's a linear variation? So what's happening here is I'm increasing the number of legs in a chair, in a table means I'm increasing the number of legs in the table. When you increase the number of legs in the table, what happens is the total load will divide also equally. Load will reduce. But if there was one leg, there will be a bigger compression. Many legs, smaller compression. It will be a non-linear variation, answer number 2. Non-linear variation. Imagine one leg means bigger compression, right? Right. Question number 9. Graph shows the variation of length of liquid columns of a certain mercury glass thermometer and alcohol glass thermometer. Mercury, alcohol. A student draws the following general conclusions solely based only on the graph. Mercury thermometers are more sensitive than alcohol. Wrong. Alcohol is more sensitive than mercury. Why? Expansivity is high. Alcohol is more sensitive than mercury because sensitivity is high. Expansivity is high. Mercury thermometers are longer than alcohol thermometers. Just looking at this, we can't come to a physical conclusion. Volume expansivity of mercury is greater than alcohol. Wrong. None of this A, B, C. All are wrong. Right there. Alcohol is more sensitive than mercury because it has high expansivity. It has high expansivity. High expansivity. We can say that for a given temperature, the expansion for mercury is higher. For given temperature, the expansion of mercury is higher. This may be because the areas of the thermometers are not equal. This may be because the areas of the thermometers are not equal. So looking only at the graph, we cannot come into any conclusion. Looking only at the graph, we cannot come into any conclusion. Right. The following table indicates 5 different sets of resistance values that can be allocated R1, R2, R3, R4. Which of the following sets produces largest deflection in the voltmeter? Largest deflection in the voltmeter means current is passing through. Right. Current is passing through. Let's see. R4. Right. R4, R3. 30 over 5 is 6. 30 over 5 is 6. Next one. R1, 20, 15. 4, 3. 2, 5. Third one. Right. So, current is passing through, not Wheatstone bridge. Not Wheatstone bridge. So, Wheatstone bridge means R4 over R3, R1 over R2. R1 over R2, R4 over R3. First one also not Wheatstone bridge. R1 over R2, 4 over 3, 5 over 2, 5 over 2, 5 over 2, Wheatstone bridge. R1 over R2, 2 over 5, R4 over R3, 2 over 5, Wheatstone bridge. R1 over R2, 6, R4, Wheatstone bridge. Right. So our problem, our answers will lie in these two. R1 over R2, 6. R4, R3, 1 over 6. Here, 4 over 3. Here, 2.5. Looking at this, biggest potential difference. Here 6, here 1 over 6, here 1.33, 2.5. Biggest ratio here, biggest ratio difference is here. So that means biggest voltage difference is also there. Right there. The biggest ratio difference occurs in answer 1. Biggest ratio difference is in answer number 1. Therefore, the biggest voltage difference will also be in answer number 1. The biggest voltage difference will also be in answer number 1. Right. The circuit shown consists of 3 fixed resistors of variable resistor which can be varied from 0 to R. 0 to R. Maximum voltage that can be obtained across XY is. So maximum voltage that can be obtained across XY is. So if you keep here Y, R, R. So you will get R, 2R, 2R over 3, R. Voltage V0. 2R over 3 times V0 divided by 5R over 3. 2 V0 over 5. 2 V0 over 5 means V0 over 5 here. So V0 over 5. V0 over 5 means answer number 1. V0 over 5 means answer number 1. When it's here at maximum resistor value at this location. Right. Particle is moving in a circular orbit of 10. At one instant, speed of the particle is 10 meters per second. Increasing at a rate 10 ms minus 2. Angle between the velocity vector. Now, increasing means there is a tangential acceleration. Centripetal acceleration is v squared divided by r. 10 squared over 10, 10. 10 and 10 square root is 10 root 2. So what's the angle between the velocity and the resultant? That angle is going to be 45 degrees. Correct answer is answer number 2. Correct answer is answer number 2. Right. Consider the following statements regarding weightlessness experienced inside the satellite. Weightless means resultant forces are cancelling off. Weightlessness is due to negligible gravity at altitude. Wrong. Gravity is there. Due to weightlessness, momentum of a person inside the satellite is 0. Weightless means resultant force. Momentum 0, you can't tell. Due to weightlessness, natural convection cannot occur. Correct. Natural convection to occur, gravity should be there. Only correct answer is answer number 2. Only correct answer is answer number 2. Right. An oscilloscope is connected to a microscope which receives simultaneously 50 Hz signal and another signal of frequency slightly more. Figure shows the trace. So you can see beat frequency will repeat. How many cycles? 1, 2, 3, 4, 5. This cycle will repeat every 5 cycles there. Here. Every 5 cycles there. So what is your answer? It's either 55 or 45. Okay? 55 or 45. So most suitable answer is answer number 2. Most suitable answer is answer number 2. Sorry. Sorry. So here, peak to peak. We consider peak to peak. How many cycles? 1, 2, 3, 4, 5. 5 cycles. Peak to peak, 5 cycles. Right. B is the combined wave. Combined wave. Combined wave means superimposed wave. Superimposed wave. So F minus 50, F minus 50 right. So for 50 hertz, for every 5 cycles, there is 1 beat. 1 beat. Every 5 hertz, there is 1 beat. So for 50 hertz, there should be 10 beats. 10 beats means F is equal to how much? 60 hertz. Correct answer is answer 3. So for every 5 cycles here, 5 hertz, 1 beat. 1 beat. 50 hertz means 10 beats. Right. A circular disc shaped pinwheel performs rotational motion along the z-axis. Assume that the pinwheel retains the shape. So they are asking you constant force. Torque is equal to I alpha. Force into radius half mr squared alpha. Force equal mr alpha divided by 2. Simplify this. 2F equal mr alpha. They are telling you that the force is constant. Constant reaction force. B is constant. So mr alpha is going to be constant. So what's the logic? When the firecracker is burning, mass reduces, radius reduces. To keep it constant, angular acceleration will increase. mr alpha is constant. Answer number 1. Answer number 1. Answer number 1. Next one. As shown in the figure, a silicon transistor, if the peak value Vi of the input voltage is 1 volt, peak value is 1 volt. Output voltage is represented by, so don't forget silicon here, 0.7 volts. Greater than that means IB current will exist. IB current will exist means IC current will exist. Yeah. IB current will exist means IC current will exist. Okay. Now, what will happen? Basically, what will happen? So here, volt here. 12 minus 0 ICRC plus VCE plus IERE. IERE. IC and IE both are equal. From this you can say 6 IC 10 to the power 3 VCE. VCE. Right. Observe very carefully. What is your VCE voltage? Input voltage is greater than barrier voltage. Right. So here look at this carefully. Now basic variation. Output voltage. Okay. Active region. Saturation region. Right. Okay. If we consider voltage amplification, there will be a phase change of pi radians. Here, there will be a phase change of pi radians. Here voltage is 10 volt now. Here voltage is 10 volt now. Now phase change of pi radians means phase change pi radians. Phase change of pi radians. So superimposing, it will reduce. What about the negative part? In the negative half, it doesn't work. So 12 volt. Again positive half, reduction. So the correct answer is answer number 5. Correct answer is answer number 5. Write this in. In the active region, VCE should be approximately equal to VCE should be approximately equal to VCC divided by 2. VCC divided by 2. And when amplification occurs, there will be a phase change of pi radians. And when amplification occurs, there will be a phase change of pi radians. There will be a phase change of pi radians. Right. Question number 70. Atmospheric air at 30 degrees having RH 80% is made to flow slowly through two large chambers. So RH is 80%. Huh? Y is maintained at 0, Z is maintained at 40. SVP at 0, 30 and 40 are given. Which of the following tables represent the relative humidity and absolute humidity of air in the atmosphere X, Y and Z. 80% absolute humidity at X divided by absolute humidity at saturation. (30 × 10⁻³ into 100. Absolute humidity at X is going to be how much? 24 × 10⁻³ kilogram per meter cube, right? Now this enters here. What is the relative humidity there? Now once it enters there, the same vapor density is there. 24 × 10⁻³ at 0 degree Celsius, it's 4.8 × 10⁻³ into 100. Simplify this. 240, 48 into 100. %. Saturation has taken place, no? Saturation has taken place. So 24 × 10⁻³ is there, means more than the required saturation will take place. So I found the absolute humidity there that enters here. This is more than the maximum possible. Saturation will take place. So in your calculation, these two look okay. These two look okay. Okay. These two look okay. Right. Then what? That vapor enters here. Now saturation 4.8 × 10⁻³. 4.8 × 10⁻³ 4.8 × 10⁻³ divided by 30 × 10⁻³ into 100. Simplify this. Right. Okay. So here you have 4.8 × 10⁻³ the rest will condense. 4.8 × 10⁻³ will enter 40. Will enter 40. That's less than. That's less than. So 4.8 × 10⁻³. 4.8 divided by 30. 4.8 divided by 30. So if you look at this, same 4.8 should be there. 4.8 10 to the power minus 3. 4.8 10 to the power minus 3. Can't be saturated. 4.8 10 to the power minus 3. So your only suitable answer, I think, is this one. Answer is answer number 2. So what is happening? From outside, 24 10 to the power minus 3 is coming in. Enters into a chamber. Maximum is 4.8 10 to the power minus 3. Saturation takes place. RH is 100%. That 4.8 minus 3 goes here. That is less than the maximum possible. RH is actually going to be 16%. Unsaturated vapor. So here answer is answer number 4. Answer is answer number 4. Question number 18. In the circuit shown, supply voltage E increases linearly with time. At a time t equal T0, supply voltage surpasses the breakdown voltage of the Zener diode. Variation of the voltage across the 100 ohm resistor and the voltage across the Zener diode is best represented by. Initially, if it's lesser, breakdown has not taken place, all the voltage will be across that. All the voltage will be across that. So voltage across the resistor will increase. Voltage across the resistor will increase. Yeah. Voltage across the resistor will increase. Then, if it surpasses the breakdown voltage, now here breakdown voltage is going to be constant. Here breakdown voltage is going to be constant. Yeah. Here breakdown voltage is going to be constant. And the difference will act across this. E minus Vz. Difference will act across that. Yeah. Difference will act across that. So, it can't be this. It can't be this. Initial voltage will be there. It can't be that for R. So, either this and that. 3 and 5. Either 3 and 5. Sorry. Sorry. Now look. Now, when I keep on increasing the voltage, current can't go. Current can't go means voltage across this will be 0. Because reverse bias. Reverse bias. So, here current will not pass through initially. Surpasses, current is allowed to pass through. Voltage here is Vz. Remaining voltage there. So looking at this, the correct answer is answer number 2. Initially voltage 0, across the Zener voltage it increases, then Zener constant, from 0 it will keep on increasing the difference. Right. Right there. Initially E less than breakdown voltage, no current. No current. Therefore, no voltage across 100 ohm resistor, no voltage. When E is larger than Vz, current passes through, voltage will increase. Okay, correct answer 2. Question number 19. Question number 19. A star rotates about its own axis as shown in the figure. Which of the following graphs best represents the observed distribution as a function of wavelength? Broken lines represent the expected intensity of the spectral lines. So right. So when this is rotating this way, light is coming more quicker, light is going away. Light is coming more quicker means frequency increases, wavelength reduces. Going away, frequency reduces, wavelength increases. So dotted lines are normal. Here it reduces, here it increases. Correct answer is answer number 1. So when it's coming, wavelength reduces, frequency increases. When it goes away, wavelength increases, frequency reduces. A uniform sheet is sent through 2 parallel metal plates as shown. Some of these defects are shown in the figure as the section passes through the metal. Variation of the capacitance with time is best represented by, right. So here thickness, when thickness increases, capacitance also will what? Increase, effective capacitance. So now when this starts moving in, thickness reduces, capacitance will reduce. Again thickness increases, capacitance will increase. Then constant. Thickness reduces, capacitance increases. Here thickness increases, so here as it goes, thickness will reduce, thickness will increase, constant. Here thickness will reduce, thickness will increase, constant. Thickness will increase, thickness will reduce, constant. So thickness reduces, effective capacitance will change. So all of you all know basic working. B reduces, capacitance increases. Now here if you take it, series, A epsilon naught D minus T times 2. A epsilon naught K T. Simplify. A epsilon naught K. Two K D minus T plus T. A epsilon naught K. Two K D minus 2. Two K minus 1. Thickness reduces, this part reduces, difference increases, capacitance reduces. Thickness increases, this increases, difference reduces, capacitance increases. So T reduces, C reduces. T increases, C increases. T increases, C increases. Right. Correct answer is answer number 4. Answer number 4. Well, the structured essay, day 3. Let's have a look. a spectrometer, sodium lamp, spectrometer, sodium lamp or flame, and a glass prism are provided to find the refractive index of glass for light emitted from sodium. Certain adjustments in the spectrometer have to be made before taking measurements. Two parts of the spectrometer can be rotated about the vertical axis to the center, independently of the other part. These are the two items. Prism table, telescope. These two can be independently rotated. Collimator we can't rotate. Right? Okay. Next one. Telescope of the spectrometer has been adjusted for parallel rays by focusing to a distant object as observed by a student through the telescope. Is the image of the object erect or inverted? Light rays coming from infinity, we will see virtual, upright, inverted images. Inverted images. Right. In this experiment, the eyepiece, the telescope, and the collimator have been adjusted for parallel rays by one student. A second student, whose near point is different from that of the first student, is to continue the experiment. What is the only adjustment the second student has to repeat? So the only thing that he has to repeat is what? Adjusting the objective lens. There. So where he is keeping the eye. Sorry. Adjusting the eyepiece of the telescope. Because his near point is different, no? Because his near point is different, he will have to adjust the eyepiece. Here. Near point is different, so the eyepiece should be what? Adjusted. Okay? Right. Prism PQR shown in the figure is given to level the prism table. Draw on the figure how you would place the prism. So one of the refracting surfaces, either PQ or PR, should be perpendicular to this line. I'll keep like this. PQ. One of the refracting surfaces should be perpendicular to the dotted lines. Right. Figure C shows cross wires and the image of the slit formed by the reflected light from the surface of the prism. It indicates two errors associated with the setup identified in. The first one is prism table is not level. Prism table is not level. This is one error. The next error is the eyepiece is slanted. So when the eyepiece is slanted, the cross wires also will be what? Slanted. So we can say the slit is slanted. Slit is slanted. So when the slit is slanted, what you will get is the slit that you see here also will be slanted. Right. In this experiment, two measurements have been taken to find the prism angle. Draw the correct location of the prism and the two best positions. So the prism angle should be facing the collimator, light rays will partially reflect. Light rays will partially reflect. So here you have the telescope, one portion here, the other portion of the telescope is here. There you go. Right. This is your prism angle A. Scale readings of the two measurements are 197, 672. The scale did not pass through the 360 mark. So did not pass through means we can take the difference. Here. So 2A is the difference. 197, 6 minutes, 72 degrees, 52. Simplify this, 66, 52. 66, 52 is 14. 124, 14. From this the prism angle you can take 62 degrees 7 minutes. Prism angle is 62 degrees 7 minutes. Right. One student argues that the source of white light can be used instead of the sodium lamp in taking the measurements of minimum deviation. We can use white light to find the prism angle, but we can't use white light to find the minimum deviation. The reason is what? Each color will have a different refractive index. Different refractive index. And the respective color images will turn at different instances. Different instances. Therefore, they will have different minimum deviations. Different minimum deviations. If the angle of the prism is A and the minimum deviation is D, write the expression for the refractive index. So N is equal to A plus D divided by 2 over sin A divided by 2. Sin A divided by 2. Okay. Sin A over 2. So N is sin A plus D divided by 2 over sin A over 2. Right? Okay. Moving on. Consider a hypothetical situation in which a point object of mass m carrying a charge q is fixed at a point in space where there is no other objects and charge present except at infinity. So if m is this equation, a second object having identical mass and charge can be brought from infinity towards the first object without doing any work. Mass is m, another mass is m. If I mark the forces, gravitational force will be there, attractive force. Here the charge is plus q. Here the charge is plus q. Here there will be a electrostatic force acting away. So without doing any work means gravitational force equals electric force. Work done by external force equals work done by resistive force. Okay. So work done by gravitational force equals work done by electric force. So work done by the gravitational force is capital G. M times M, let's say, brought to a distance r square times, let's say, x. Here electric force is q squared over 4 pi epsilon naught r squared times the distance delta. Simplify the relationship, x cancel off. From this you can say m square is equal to q squared r squared cancel off 4 pi epsilon naught capital G. Please take the square root. M is equal to q divided by square root 4 pi epsilon naught G. M is equal to q over 2 pi epsilon naught G. So if this is equal, we can say no work is done, right? Write a small sentence there. If there is no work done, if there is no work done, so what we'll do is we'll use the board for this. Roman 1, no work is done. M and M, here there will be a gravitational force plus Q, there will be a repulsive electric force. So no work done means gravitational force equals electric force. Capital G, M times M over R squared 1 over 4 pi epsilon naught q squared over r squared. M squared is q squared over 4 pi epsilon naught capital G. M is equal to q over 2 pi epsilon naught G. Pi epsilon naught G. Right. Okay. Next part. Now I did it here. This part I did it here, but I'll do this also. M is larger than this value. Work is done by the object. Let's see. Now if M is larger means gravitational force is greater than the electric force. Capital G, M over R squared, q squared over 4 pi epsilon naught R squared, M squared, q squared, 4 pi epsilon naught G. M is larger than q, 2 pi epsilon naught G. So work is done by gravity. Work is done by gravity. So work is done by the object. So easily we can say work is done by gravity on the object. Right. Next one. If M is smaller, work has to be done on the object. Right. Part B. This is part A. Part B. What if electrostatic force is greater than gravitational force? To bring the object, we must do external work. So q squared over 4 pi epsilon naught r squared, capital G M squared over r squared. Simplify this. Simple M is smaller than q over 2 square root pi epsilon naught G. Electric force is larger than gravitational force. Therefore, work is done against the field on the object. So if the electric force is larger, the object will keep going away. To bring it back, I must do some external work. Okay. What is the total work that has to be done when bringing the second object from infinity to a point at a distance simple r from the first object, under the statement Roman 1b. Roman 1b means electric force is larger than gravitational force. Right, electric force is larger than gravitational force. Look at the board. Right. This is Roman 2. Roman 2. Right. So Roman 2, mass is here, charge is here. Mass is here, charge is here. From infinity only we are coming. Huh? Total energy at infinity equals total energy at A. Gravitational potential energy, elastic potential energy at infinity. There is no kinetic energy. Here, total energy at A, gravitational potential energy plus elastic potential energy at A. If you look at this, work done to bring the object. So, we must do some work. Here, we must do some work to bring the object. We must do some work to bring the object. So, external work done. So, gravitational potential energy 0, elastic potential energy 0, or electrical potential energy 0. Here, minus capital G, m times m over r, plus potential q over 4 pi epsilon naught r times q, plus the work done. So work done is equal to capital G m squared over r minus q squared 4 pi epsilon naught r. So the work done is capital G m squared over r, capital G m squared over r minus q squared over 4 pi epsilon naught r. So we are doing some work. Where is the work done? Work is done at infinity. 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 Q squared over 4 pi epsilon naught r minus G m squared over simple r. So apart from the energy, I must doing work. I have to do work at infinity. Apart from the energy, work at infinity to bring the object here. Okay, now next one. Next one. State under which condition given in Roman 1, second object has the capability of existing in a circular orbit around the first orbit. So under what condition? Gravitational force should be greater than electric force. So under what condition? Gravitational force is larger means part A, Roman A. Roman A. So A, m is larger than q over 2 pi epsilon naught g. Gravitational force is larger than electrostatic force. Right. Next one. If the second object moves in a circular path of radius r with a velocity v naught, write an expression relating simple r. Right. So now circular motion. So if you take gravitational force, electric force, object is going in a circular path, orbit radius simple r, tangential velocity is v naught. So centripetal force, mass into centripetal acceleration towards the center O. Gravitational force minus electric force, m v naught squared over simple r. Gravitational force is capital G m squared r squared, q squared over 4 pi epsilon naught r squared, m v naught squared divided by simple r. What are they asking you? Write an expression relating simple r. Write an expression relating simple r. Right. So we can remove the simple r. Capital G m squared over simple r, q squared over 4 pi epsilon naught simple r, m v naught squared, m v naught squared, 1 over r common, gm squared, q squared over 4 pi epsilon naught, m v naught squared. Make simple r the subject, gm squared, q squared over 4 pi epsilon naught, m v naught squared, m v naught squared. There you go, relationship found. Relationship found. Next one. An asteroid of mass m located far away from a certain planet of mass m starts to move towards the planet due to gravitational influence. Assume that the planet is stationary and there is no gravitational influence on the asteroid and other celestial objects. The speed of the asteroid when it at a distance r is v. Derive an expression for the magnitude of the charge that is to be placed on each of the objects at that instant in order to stop the asteroid at a distance r over 2 and reverse its motion. Right. So now you can see the problem. There is a planet mass capital M. There is an asteroid mass simple m. At a distance capital R, the velocity is v. At a distance capital R, the velocity is v. Right. Now we need to stop it. Our job is to stop it. Stop it at a distance r over 2. M comes to rest. Don't forget there is a charge as well, plus q. What is the charge that should be placed? Each of the objects, so both objects. Right. Right. So let me apply xy. Total energy at x equals total energy at y. Gravitational potential energy, electrical potential energy, kinetic energy at x. Gravitational potential energy plus electric potential energy at y. So minus capital G, capital M, simple m over r. Electric potential energy Q divided by 4 pi epsilon naught r multiplied by the charge there. Kinetic energy half m v squared goes by here r over 2 minus capital G, capital M, simple m r over 2. electrical potential energy, multiply both the charges 4 pi epsilon naught R divided by 2. R divided by 2. Simplify this carefully. If you rewrite this, Q squared over 2 pi epsilon naught R minus Q squared over 4 pi epsilon naught capital R, that is equal to 2 capital G capital M simple R minus capital G capital M simple R. So this goes here, this goes there, plus half M V squared, Q squared common 4 pi epsilon naught R, 2 minus 1 is 1, G capital M simple M R, half simple M V squared. Q squared is equal to 2 capital G M simple M plus MR V squared over 2R. Multiply by 4 pi epsilon naught R. 1 R will cancel off, 2 times 1, 2 times 2. Square root. Q is equal to 2 pi epsilon naught 2G capital M simple M plus MR V square. Square root. From this you will get your final relationship. So if you simplify it, you get the relationship. Okay. So apply total energy at X equals total energy at Y. Okay. Right. Right. So this concludes the discussion. Final countdown. Week 8, day 3. So catch you next week with another exciting episode of Final Countdown. So next week we'll be discussing the 2007 A-level paper. So we have finished altogether from 2000 to 2006. 2000, 2001, 2002, 2003, 2004, 2005, 2006. 7 papers have been completed and finished. If you look at it, 60 MCQs into 7, 420 MCQs. 420 MCQs. But 60 into 8, 480 MCQs. 480 MCQs. So every week, what we normally discuss is 3 essays. 24 essays done. 3 structured, every day 1 structure. 8 weeks, 24 structured essay done. So you can see the amount of work that is now completed and finished. Okay. 480 MCQs, 24 essays, 24 structured essays. So don't delay. Please start working. The videos are there, you can watch it. But keep working back again. It's never late. It's if you give up on me, you will be what? If you give up, you will lose. As long as you don't give up, you will never lose. And you can't lose. Okay then. Catch you all tomorrow at the same time. Final countdown, week number